Welcome to Perspectives with Wenchi Yu, where we analyze the policies and political strategies of Trump 2.0 and their implications for Asia, China, Taiwan, and beyond. With Trump back in power, U.S. semiconductor policy is also back up in the air. At the center of the race is access to the kind of high-end semiconductors used to power the vast data needs of AI. Key to making those advanced and difficult to manufacture chips are what's called EUV, or extreme ultraviolet lithography machines. Currently, the Dutch company ASML is the only firm capable of making them. Since 2019, the US has pressured ASML not to sell its EUV capabilities to China, and in 2024, the Netherlands follows suit by adding its own export controls. Predictably, China hasn't taken this lying down. It has spurred research into alternative technological approaches. There have been multiple recent reports about China's breakthroughs in developing EUV that boast of high energy conversion efficiency, low cost, compact size, and relatively low complexity. In other words, a game changer. These new Chinese-led advancements in EUV lithography could open the door for China to develop its own advanced semiconductors and bypass the sanctions imposed by the United States. Today, we're talking to Marc Hijink, a Dutch business journalist and author of one of the best books on the technologies and policies at the heart of this history. Marc believes China is still 10 to 15 years behind in manufacturing and deploying a large number of EUV machines. His book is called The ASML Way, and it came out last year. It's an excellent read. I'd urge you to get a copy of it from Amazon. It's also available in other languages. Welcome, Marc.
Thanks, Wenchi, for having me. My name is Marc Hijink. I'm a Dutch journalist. I work for a national newspaper called NRC. And as a financial reporter, I cover mainly technology companies. And of course, the biggest technology company in the Netherlands is ASML. And ASML is the manufacturer of chip machines, especially lithography machines. And you could describe them as giant copiers, very complex giant copiers used to produce, mass-produce semiconductors. So the chips you find in your daily devices, in your phones or your cars or your refrigerators. But ASML is like the only company that's capable of building machines that can create the most advanced chips. And you can find these chips in the AI data centers or in the NVIDIA AI chips. And in general, you could say that without these machines ASML makes, there wouldn't be this, present-day AI hype or AI revolution.
Yeah. Help our audience who doesn't understand the division of labor among all these key companies, right? So let's say you have NVIDIA that designs some of the most advanced chips, and then you have TSMC that literally manufactures chips. And so what is ASML's role in between all this?
Well, if you look back, ASML and TSMC have been cooperating for quite a long time. This relationship goes back right to the 80s of the last century when TSMC was founded. And ASML was like one of the first companies that cooperated with them and supplying the chip machines necessary for manufacturing the designs like NVIDIA's. And you could call this lithography machine, this giant copier that ASML produces. Well, it's like the oven in a bakery. It's the machine that is capable of printing these really fine lines on a silicon wafer.
ASML somehow is less known unless you pay a lot of attention to the semiconductor.
That's right. It's kind of an obscure company, but the machines they make, they're like this crucial part in any fab. They have like a 90+% market share in lithography, and I think their footprint is over 5,000 lithography systems throughout the world, and you find them on any continent. And
do they have any competitors right now?
They do have competitors, but they're pretty small, relatively small. If you look back, then ASML has been a market leader I guess, since the early 2000s. And their main competitors used to be the Japanese companies like Nikon or Canon. And also there's a Chinese competitor called SMEE. ASML's in the most mainstream technology, it's a definite market leader, a very dominant player. And on the most advanced technology called EUV, extreme ultraviolet light, it's a monopolist. ASML regards itself as the Switzerland, so it's like a neutral player. Yeah, because being such a dominant player, the whole world, or the whole semiconductor supply chain is like depending on this one company. And they realize they have to be a neutral player, which is very hard these days because there are a lot of geopolitical export restrictions.
Maybe you can help us understand just how large China is a market in terms of its share for ASML's global business.
Well, excellent question. Because last couple of years, if you look at ASML's revenue, the market share of China has been quite skewed. Back in 22 and 21, there were a lot of Chinese orders, and ASML couldn't actually deliver on a lot of them because their own supply was constrained. And so there were a lot of other orders that had to be supplied first, and then there's still a lot of Chinese orders coming along in the years of 23 and 24. So you could see the share of China in ASML's revenue grow to 40. Sometimes some quarters it was almost 50%.
So you were saying a lot of orders came in around 2021, 2022.
Yeah.
Was it for any particular reason? Because the export control policy hadn't taken place back then, right? So why was there so many Chinese companies who wanted to order ASML machines?
I guess your question is actually the answer, because the export controls hadn't taken place, but there were going to be. And
they were expecting it.
Yeah. So it's just a matter of being there being there at the right time before the export controls hit. So they placed a lot of orders, and ASML first had to take care of all the other orders that were already in. But then something else happened, which is like a decline in the semiconductor industry. There was a downturn, so a lot of other ASML customers, they paused their orders, and this way the Chinese orders, I got early in the road to be supplied, and that's one of the explanations that the Chinese part of ASML's revenue was growing so rapidly, and they expected to normalize it in the next year, so in 25.
So
for two reasons.
What would be a normal percentage like? Are we talking?
I think if you look back, it's about 15 to 20%. But of course, China is growing as a market, and not in the advanced chips, but there's a lot of chips, mainstream chips or mature technology that's being used throughout the industry in your refrigerators or washing machines or microwaves. And these are like common chips that everybody needs, or in their EVs or in windmills. It's not the cream of the crop technology, but it's being needed and being sold in massive amounts. It's very expensive to produce chips, because if you repeat the lithography process multiple times in one layer, then the yield is lower, which makes it a very expensive chip to make. So China is restricted on that really advanced technology, and you see China's attention growing to the less advanced technology because there's volume in it, there's money in it as well.
Let's talk about the U.S. export control policies that were issued in 2022 when the first Biden administration's executive order came out. How has that affected ASML?
Well, it has affected ASML's revenue slightly, but not in a big way, because it's all depending on, well, the total demand for chips. And ASML, being this dominant player with a huge market share, has the very simple philosophy saying, well, if this demand can't be meted in a country like China, the demand will be in other countries. So they have to use lithography machines from ASML anyhow. So our revenue won't be hurt that much.
If China demands so much, but all of a sudden the demand goes down, where else are you going to find the demand?
So there's the export restriction on EUV technology. So that's the most advanced.
Most
chips.
advanced,
Yeah.
yes.
And ASML's philosophy is, okay, if China can't produce these very advanced chips, there's still a need for these very advanced chips, because, well, that's what the world needs for the AI revolution. So they're going to produce somewhere else. And if these fabs are going to be built on another continent or in another country, they're going to need our machines. So it's just a shift in region. It's not less revenue.
The global demand is so high that basically the demand to develop AI technologies,
Yeah,
it's
I
so
think that's
high.
a nice way to sum it up. And there's you could regard ASML as a player who says, well, we do have one competitor, even though we have a huge market share, and this is the economy. So when the economy is going down, there's less demand for chips, because, well, people buy less stuff, or innovation slows down. So when there's less demand for chips, there's less demand for chip machines. And that's, well, of course, ASML feels it in their revenue.
So that's about the most advanced part. What about the other part in terms of the export control policies impact on maybe non-EUVs?
So what the export controls were aiming at was lowering the amount of chips China could build that kind of resembled these very advanced levels. And so they restricted ASML from exporting the machines that one would use for multi-patterning. And that's the process I just explained, like doing multiple lithography steps on one layer. And so that's the top layer of these DUV machines can't be sold to China anymore. And these are less expensive machines than the EUV machines, because these EUV tools, well, they cost $200 million
per machine.
Per machine. In the most expensive ones cost $400 million per machine. And if you compare that to the advanced, previous generation, that's about 60 or 70 million. So there's a difference, which means there's less impact on ASML's revenue. The lithography machine is not the only machine you need for this multi-patterning process. So it's like this combination, this orchestra of other machines that are also in the chip fab that are needed to do the deployment of new layers or do the etching. And these come from US suppliers, and these US suppliers are now also restricted to export their most advanced machines to China as well. And the end result is that China is finding the place in the market where there's still room to grow, which is the even more mature chips. And there's a huge market for that, especially if you look at power chips or just plain Wi-Fi chips, everything we use in our daily devices that's being produced out there. And they're using ASML machines for that.
So the most advanced machines aren't really affected, right? Because they never really go to China, as I understand it. However, the large part that's affected ASML the most is advanced chips, not most advanced, that basically China consumes a lot.
If you shut down China now completely, just hypothetically, you're gonna create a chip shortage, just like the chip shortage we experienced during COVID, when we had to wait for our new cars or PlayStation 5. Because there was not enough semiconductors in the supply chain. And the end result was that these car manufacturers had to pause their product line because they were just waiting on chips. So this is like a nightmare scenario. Prevent that, you don't want to restrict China from building these relatively cheap chips, too rapidly, too harsh.
Do we know what is the percentage of chips in the world supplied by China? Is there any number like that?
There are several numbers out there. There's a way you can look at the numbers in a way that you describe the revenue that's generated by the chips, or the chips that are being produced in China by companies from other countries, or like internationals, because they're like Samsung fabs and TSMC fabs in China as well. But if you look at the domestic part, or the domestic industry in China, I think it's about between 10 and 20%, and it's growing, but the majority is still mainly in Taiwan.
With the added export control policies, how did that affect the Dutch-China relationship?
Well, I don't think there's a lot of chips in the trade between China and the Netherlands, but mainly machines. And I think there's a clear dependence from China on the Dutch semiconductor or high-tech equipment, and also ASML supply chain. So the Chinese way of perceiving these export controls is that the Dutch were kind of pushed by the US to take these measurements to restrict ASML.
So there's the company ASML, which is obviously a Dutch company, and there's the Dutch government, right? That's probably getting a lot of pressure from the US government.
It is.
And so how do they interact with each other?
You mean ASML and the Dutch government?
Right.
Well, of course, when it comes to rules, it's not ASML that thinks of its own rules. It's the Dutch government they have to listen to. And but because it's a complicated market, ASML really reached out to the government and their officials to educate about these. I call them these brittle change in the supply chain, because it's there's a lot of single sourcing there, and if you just cut out certain parts of the supply chain, you're gonna create problems in the somewhere else on the planet. You don't realize you could actually influence, and I guess that's a lot of education that ASML provided, and also because it has a lot of these sensors or feelers or data from chip fabs throughout the world. It really has great insight in what's happening at the customer base. This helps the Dutch government also negotiate with the US government and the Japanese government, and saying, okay, well, if you're gonna alter this in the supply chain, you might hurt yourself in the end. I guess that's the way that ASML is trying to guide this process. But in the end, they have to realize they have to. Well, they're just a company. They have to follow the rules, and the rules are targeting China that's becoming more aggressive in an economical way. And I guess that's ASML is just part of the equation, and you could call it like the insurance policy for U.S. protection in Europe, and so it's part of that geopolitical fight between the U.S. and China.
So much of the U.S.-China tension has been going on for years, and the rest of the world is feeling it. Sometimes taking a side, sometimes maybe not, trying to stay neutral. In this particular case, while ASML is getting the pressure to restrict its export of machinery to China, has there been any other European countries' pressure, or EU as a whole? Do they take any stance?
The Dutch government was kind of alone at this topic, which is weird because
alone ASML, in what way?
Alone when it comes to dealing with the US. So the Netherlands is just a small country. If you compare to the US, the economy of the American economy is like 20 times the economy of the Netherlands. So it's not a level playing field on that part. But the Dutch do have some negotiations because they have this very rare supplier that everybody's depending on within their borders. But if you look at ASML, their headquarters is in the Netherlands, and their history is in the Netherlands, and a lot of their knowledge is in the Netherlands. But that their supply chain is for a big part is a European supply chain, and their cooperation, very tight cooperation with German companies like Trumpf, which supplies the laser, or Zeiss, which a crucial supplier which supplies the optics system. And also the cooperation with IMEC, the Belgian Research Institute, very close to the ASML headquarters. That's like the playground for all international players in the semiconductor industry. These are all like pieces of the puzzle. These are European pieces of the puzzle. So it's kind of weird that the Dutch were out there on their own, negotiating with the US without any support from their European members. And the member states have these national, they all have their own export control rules. That's like this national capacity they don't want to share with other member states of the EU. I think especially nowadays, when there's so much pressure from these other superpowers, the US and China, it's time for the EU to gear up and create a
more united front.
A more united front, especially when it comes to protecting your own germs or these special companies like ASML.
So you said there's less united front in resisting the US pressure. And how did China respond to this situation?
If you look at the official answer, there has been some reply in also export restrictions on certain kind of rare earth or metals. But you could say these were not very harsh measurements that from the Chinese. The Chinese restrictions on gallium and germanium didn't have a direct impact on the industry, but it was more like showing, we can do this. We have this opportunity because we're dominant in this field of rare earth and rare minerals that the whole world is depending on. So China was like flexing its muscles. But in the meantime, there's this shift in China's aim to create a domestic semiconductor market, so it doesn't have to depend on any Western countries or companies anymore. The Chinese have upped their game. So if you look, for example, at Huawei, used to be a telco company. It's now very much diving into the semiconductor market. It's trying to unite all these several attempts of Chinese companies to also innovate. There's a lot of subsidy going into and state support going into these attempts to recreate, for example, lithography machines, but also other machines that are being replaced in the chip fabs.
The DeepSeek moment was a wake-up call to a lot of companies, because Silicon Valley or the US has always thought US dominance and leadership in AI is so much more advanced than other countries, including China. Now, ASML's position is similar in that sense.
Wenchi, if I can add to that, I think it's I think you should be careful in comparing a software development to a hardware development, because the barrier of entry for hardware innovation is very high. Software is, especially when it comes to open source developments like DeepSeek. Of course, these are brilliant engineers that or developers that have thought of a new way of using less compute to create viable results in LLMs. Building a lithography machine, there's a reason that ASML has this huge market share, because it's very hard to replicate. Chinese companies have tried buying these machines, taking them apart and trying to get it working again, to replicate it, but they haven't been
able to. What's the unique sauce that ASML has that Chinese, for trying so hard, still can't?
The lithography machine is like this nexus of problem. So that it's multiplication. Not only is it sheer physics, because you're working on the nanometer level. So we're talking about atoms. You're talking about chemistry. You're talking temperature, gravity, or vibrations, or even methane. In the book, I call it cow farts. Even cow farts from kilometers from the fab can have have their impact on semiconductor manufacturing. And ASML's machine is capable of kind of predicting and keeping it together with software. So they actually use a lot of AI to keep all these moving parts together. And I guess a lot of the secret sauce is in the culture, because if you have so many complex problems to tackle, you really need to save time. You can't beat around the bush when you're not capable of solving everything. So it takes a very direct culture, which is typically a Dutch thing, and it's also an engineering culture. Funny thing is, if you work at ASML, as I experienced when writing the book, it's a very challenging environment. Not only it's challenging to work with colleagues who always try to find failures or errors in whatever you're producing, but you're also supposed to challenge your leadership. And especially in cultures outside of the Netherlands, this is kind of a counterintuitive thing. Are you really supposed to, criticize your boss? Well, yeah, if you want to solve problems, because if you have to depend on your boss knowing everything, it's kind of like a bottleneck.
Same thing with the argument around TSMC. Some people believe that you can just take TSMC and relocate it somewhere else and it'll work. I think similar to what you said, it takes so much more. It's like creating a meal that requires some of the secret ingredients, and if you put it in a different temperature, or if you are literally using different water.
Some of the engineers who helped me explain the technology, they compared it to, if you can drive a car, you could potentially just get into a Formula One and F1 car and start it even, but at the first corner you're just gonna have this huge accident because you don't have the experience to run a machine like that. It's not only about building machine, it is also about keep
using
it
it,
running.
operating. Yeah. There's the news coming from China that I think it was the Harbin Institute of Technology recently has developed this new technology that is comparable and competitive to the EUV. Some people may say, oh, look, that's another Sputnik moment. And is ASML's leadership position going to be challenged? But according to what you just explained, software is different than hardware, and the barrier to entry is so much higher. So you still believe that ASML is way ahead?
Well, if you look at the aim or the goal of the Chinese researchers, it's of course to create their own EUV or EUV-like technology, which makes sense because they, in their point of view, because they want to have this domestic industry. So
they don't
there's
want
a lot
to
of
be dependent on someone else that they cannot control, obviously. Yeah.
But looking back, if you see where EUV was coming from, because it's just like 3 letters, but of course there's a lot of technology behind it, and there has been research in EUV technology since the late 90s. And I think the first machines, the prototypes, were built by a corporation which was funded mainly by Intel in the early 2000s. So this technology has been out there for a while, but there was only just one company which was crazy enough to spend so much time and throw so many engineers at the problem. And it took 8 years longer than expected for ASML to conquer it. And even nowadays, the EUV machine is still not finished. So ASML got to the level that it was economically viable machine. So there were enough wafers per hour coming out of the machines to to gain back all the investments because these are very expensive machines. It took 8 years longer than expected. Or the general consensus is that China will, of course, they have brilliant minds there in China. They have a lot of innovative students coming from the engineering schools and universities, but it will take them, that's the general consensus, 10 to 15 years to catch up. Of course, in the meantime, ASML's and the rest of the Western world is innovating and is getting to a next level.
Sounds like it's a much bigger gap to close. Chinese Vice Premier Ding Xuexiang just visited the Netherlands after Davos and met with the Prime Minister, the King, and also talk about the global supply chain of semiconductors. What did they talk about, and was that going to influence Dutch policies in any way?
I wasn't there during the talks, so I guess one of the subjects was, of course, the high-tech industry, and not only ASML, because there are a lot of other companies from the Netherlands that are very active in Suzhou, or in Shanghai. So if you look at the general attitude to investments in China, you see a reluctance of Western companies to grow in China. FDI numbers have been dropping recently, and China has become less attractive as a market, not only because of export restrictions, but also because of
its own economy,
politics. And so you see this de-risking strategy throughout the supply chain, also in the Netherlands. Yet on the other end, there are a lot of Dutch companies that really feel attracted to the Chinese market, even though the Chinese economy is in a downturn right now. They expect it to recover, and they want to be there when it recovers. So there's this two-sided approach, building local for the Chinese market, and de-risking and taking expanding in other South Asian markets. For example, Malaysia, Singapore, Vietnam. And you see these suppliers of ASML, they also supply to US companies like Applied Materials or KLA. And they don't want to be dependent on
Chinese market as well.
Chinese supply chain, because, well, they might get in trouble if something clogs up there.
The US has a new administration, a new president that is rather unpredictable. It's very unclear what his semiconductor policy is going to look like. And I don't know if he actually has one yet. And so what does that mean for a company like ASML? What does that mean for the Netherlands as a country? And then, you know, the EU?
Wenchi, if you look back at when all this started, it was during the first Trump administration. So it was like the first Trump administration that kind of rediscovered this instrument of using export controls to regulate it. And it was also the first Trump administration that tapped the Dutch government on the shoulder saying, hey, ASML is trying to sell these EUV machines to the Chinese customer. Please tell them to stop. A lot of chaos and also unpredictable events, because Trump's likes making deals. So Biden was more consistent and also on a multilateral approach. So he reached out to the Netherlands and also to Japan to create like this trilat negotiations,
like alliance,
and this alliance kind of worked, but it worked kind of slowly. And I think the new Trump administration will get back to the try to have these speedy decisions to the element of surprise. That's what I expect for it to happen. That's why everybody wants.
How is everyone preparing for that?
Well, I guess the best way to prepare is to don't gamble on any one continent, but to spread out your risk throughout the planet.
Diversification.
Yeah, and diversify. That's what all ASML suppliers are doing. And don't forget that 80% of these huge chip machines ASML builds is being outsourced to other companies. So it's really important to have this supply chain in the US, in Asia, also in China. It's just plain de-risking. I don't agree that we don't know what Trump is doing. I think he was pretty outspoken when it comes to, for example, the CHIPS Act and to subsidizing foreign companies to invest in chip manufacturing on US soil.
Well, instead, he wants to raise tariffs. And he also announced that he was going to impose tariffs on semiconductors. And we don't know when and how much and the details yet. And if that is the case, how's that going to affect ASML or?
I think Trump's strategy is mainly causing a lot of chaos also on the other side of the table, and to create an impact, and this helps him during negotiations, and these new negotiations might turn out completely different, and which is a tactic that sometimes works and sometimes it doesn't. In general, it's very expensive to build a fab and build it somewhere else where there's no ecosystem, or there's less talent, or there's less discipline, or a different culture. And we're talking about not only the money. So it took TSMC quite a while to get this first fab in Arizona running, for example. And I think there's still a lot of Taiwanese employees and a lot of Taiwanese expertise working there north of Phoenix to keep things running. But if it's just choosing between that and some extra dollars per chip, I think it's way easier to just pay the extra tariff than building a chip fab without any support, because it's a very expensive hobby, so to speak.
Do you foresee that happening to SML as
I think the cost will go up, and that's also what I describe in my book. I think the first victim of this tech war, the technology war, is Moore's law. Because Moore's law is like the doubling of the amount of transistors every 2 years, and this has been the pace of the innovation.
and this might slow down, basically.
Yeah, and it might slow down because the economies just change, and not only when it comes to these very advanced AI chips or possible AI scenarios for the future, but also for our daily lives, the way we connect with each other. It makes sense for the chip industry to have a different economy model, not only based on scaling down the chips and creating and replicating these fabs on just one continent, but making sure that the world can depend on the technology in general. And it's going to cost you.
This podcast was recorded on February 6th. Since then, there have been additional reports about significant breakthroughs in Chinese EUV technology. Therefore, an important question: are efforts to slow China's progress in semiconductors and AI development working, or are they backfiring? The answer is likely somewhere in between. Previous guests on the podcast have affirmed the negative impact of restricted access to EUVs on China's ability to develop advanced chips. However, this does not preclude China from developing its own alternatives. So a more critical question is, what is the ultimate goal of U.S. semiconductor export policy if slowing down China's progress may not sufficiently justify the realignment of the global manufacturing supply chain? This is Perspectives with Wenchi Yu, where we analyze the policies and political strategies of Trump 2.0 and their implications for Asia, China, Taiwan, and beyond. Thanks for listening to our 8th episode and 3rd in a 3-part series about semiconductors and geopolitics. We value your feedback. Please subscribe to our YouTube channel and podcast. See you next week.